Hey guys, welcome. We're going to do this geometry homework, area and perimeter. So it says find the area of the shaded region for all questions. Assume that the squares look like squares and things that look like circles look like circles. Okay, great. Now I'm going to, this is actually stuff you've learned before you met me, but maybe you haven't had in a while. So this is kind of a review. Also, questions like these come up on standardized tests. So they're very popular questions just in geometry in general. So let me give you a basic idea. This is a 3x5 card. It's called a 3x5 card because it's about 3 inches by 5 inches. So let's assume this really was, it's technically a little off, but let's assume it was a 3x5 card. So the area is base times altitude. Boo, splat, that is a 90-degree angle, so technically that's an altitude. So the base is 5. And the altitude is 3. So the area of this would be 15 inches squared. 15 inches, 5 inches times 3 inches would be 15 inches squared. Okay, so how could we calculate something of an odd shape? Well, let's say that a part has been removed. So let's say we cut off a 1x1 square here. So if we cut off a 1x1 square here, and we cut off a 1x1 square here, then the area would be the whole, this is the area of the whole thing, minus the area of what we cut off. So what is the area of what we're going to cut? We're going to cut a 1x1 square, and another 1x1 square, plus another. So we're going to cut off 2 1x1 squares. So that would leave the, whatever I have left, 13 inches squared. So let's do that. So that is 1x1, right? And that's 1x1. So if they ask me, find the area of this, the area of this thing is 13 inches squared because it was 15 before I cut 1 inch squared off and another inch squared off, okay? So this is the concept. The shaded region is always, the area of the shaded is equal to the area of the whole thing minus the area of the unshaded. Okay, so this is our general formula that should work really nicely. The area of the shaded region should equal the area of the whole thing minus the unshaded. Now we can write out those words, but hopefully you're getting the point. So what is the area of the whole thing? That's just a square. So the area of the whole thing is a square. So that'd be base times altitude, or 10 times 10. So the area of the whole thing is 100. Now, what part do they cut out? Well, they're going to cut out this circle and that circle. So 2 halves make a whole. So the area of the unshaded would be a half of a circle plus another half of a circle, which is just 2 halves of a circle or 1 whole circle. So what is the area of that circle? Okay, the area of this circle, the area of any circle in the universe, is pi r squared. So let's figure out what would be our radius. So, okay, if this is the center of my circle, the radius would be 5 because the diameter is 10. Is that making sense there? So the radius has to be 5. So this is 5, that's 5, that's 5. All of the radiuses for both of these circles are 5. So what is the area of my unshaded region? That would be pi 5 squared, or 25 pi, 5 times 5. So what is the area of the shaded region? This part. It would be the area of the shaded would equal the whole area, 100, minus the shaded. And yes, we would leave our answer looking like that. Fun, right? Let's do another. Question number 2. What's the area of the whole thing? Area of the whole thing is a circle. So that's pi r squared. So the circle is 7. So pi 7 squared, or 7 times 7 is 49. So yeah, 49 pi. Now, again, my formula is the area of the shaded region has to be the area of the whole thing minus the area of the unshaded region. So let's find the area of the unshaded region. The area of the unshaded region is a square, because it says if it looks like a square, it is a square. Ooh, but this is hard. That's not my altitude. Boo! Splat. Right? That's not my altitude. That's my altitude. And I need this number, the base and the altitude. So I need more information here. I know this is 45 degrees, right? And this is a square cut in half. So working backwards, I can use my special, the legs are equal, and the hypotenuse is equal to the leg times the square root of 2. So the hypotenuse here is equal to 7, and the hypotenuse is equal to the leg times the square root of 2. So let's get the leg by itself on one side. All right, so we have leg is equal to 7 divided by the square root of 2. So this leg is my altitude, and it is 7 divided by the square root of 2. And that's this dimension. It would also be that dimension as well, right? It would also be this dimension as well, 7 divided by the square root of 2. This would be also 7 divided by the square root of 2. So this bigger shape, this unshaded region should be 7 and another 7. So a total of the base should be base times altitude. The base should be 14 divided by the square root of 2. And the height would also be 14 times the square root of 2. And we can't leave our answer like that. But notice what happens. 14 times 14. Square root of 2 times the square root of 2 is the square root of 4. The square root of 4 is actually 2. So that worked out nice. 196, or 14 times 14, yeah, divide by 2 is 98. Okay, so the area of my shaded region is 98, and now we can finish out the problem. The area of the whole thing was 49 pi, and the area of the shaded region was 98. All right, let's do another one. The area of the whole thing, so the area of the shaded is the area of the whole minus the area of the unshaded. The area of the whole thing would just be 8 times 10, right? The area of the unshaded would be 5 times 8. So we get 80 minus 40 is 40 feet squared. All right. Next one, the whole thing. Area of the shaded is area of the whole minus the area of the unshaded. All right, so the whole thing has a radius of 5 and 3. So the whole circle has a radius of a total of 8. So that's pi 8 squared. And then what about the unshaded region? The unshaded is a circle, pi radius 5 squared. So I get 64 pi minus 25 pi's. And we can treat those like x's. So I have 64 pi's, take away 25 pi's. We can combine those terms. I get 39 pi's. And this is an area, so that would technically be centimeters squared. Okay, let's keep going. Oh, this one feels like my note card example. So I have the area of the whole thing, right? Area of the shaded is area of the whole minus area of the unshaded. So the whole thing is 5 and 4 and another 5, so that's 14. And this is also 14. So the whole thing is just 14 times 14. Okay. What about the unshaded? So that's 5 by 5, 5 by 5, 5 by 5, and 5 by 5. So it is 4 5 by 5s. You could add them up. So the area of this is 25, 25, 25, 25, right? Or you could just do 25 times 4. So I get 196 minus 100, because that's the area of the unshaded, should be 100. So I get a total of 96 meters squared. Okay. This one's interesting. This is saying this is a square and this is a square. So very interesting. This distance and this distance are the same because this is a square. So this distance and this distance are the same. So what that tells me is this would have to be 3. This would have to be 3. That would have to be 4. That would have to be 4. That would have to be 3. All these little triangles are equal sizes. And hopefully you're noticing this is a 3, 4, 5 triangle. So the area of the shaded is the area of the whole minus the area of the unshaded. So what's the area of the whole? Well, it looks like the whole thing is 7 by 7. 3 and 4 make 7. 3 and 4 make 7. So the area of the whole thing is 7 times 7. What is the area of the shaded region? Well, this is a 5 by 5 because this is a 3, 4, 5 triangle, right? So that would be 25. So I have 5 times 5, right? So 49 minus 25 gives me 24. Units. They didn't give me units, so I could just say units squared. I don't know how many units, so I'll just say, I don't know if they're centimeters or inches. Check out the next video for the back